On the ocean floor, where light fades and movement slows, survival favors stillness. Here, among shifting sands and silent currents, lives a fish that abandons symmetry to remain alive. The flatfish does not chase, does not sprint, does not leap. It waits, pressed against the seabed, almost invisible. It watches the world from an angle no other fish has chosen. Flatfish belong to an order known as pleuronetiforms, a group that includes flounders, soles, halibut, and turbots. At first glance, they appear almost unreal, as if nature paused mid-design and never corrected the mistake. Their bodies are flattened sideways, one eye pressed uselessly against the sand, the other staring upward into open water. But this impression is misleading. What seems like a flaw is, in fact, one of evolution's most radical and successful experiments. Flatfish are not born this way. As larvae, they begin life swimming upright, symmetrical like most other fish. Their eyes sit on opposite sides of the head, their bodies vertical, their movements ordinary. But as they grow, something extraordinary happens. One eye begins to migrate, slowly sliding across the skull until it joins the other on the same side. Bones shift, muscles reorganize. The fish rotates its body and settles onto one flank, committing itself permanently to a sideways existence. This transformation is not cosmetic. It is total. The side that faces the sand becomes pale, almost blind, and functionally dormant. The upward-facing side darkens and gains complex pigmentation patterns, allowing the fish to blend seamlessly into its surroundings. Sand, gravel, mud, even patterned seabeds are mimicked with astonishing accuracy. In a matter of seconds, a flatfish can vanish completely, leaving behind only empty ocean floor. Life at the bottom demands patience. Flatfish are ambush predators, feeding primarily on crustaceans, worms, mollusks, and smaller fish. They do not pursue prey. They wait for it to come close enough. When it does, the flatfish strikes with sudden speed, launching upward from the sand and engulfing its target before sinking back into stillness. Energy is conserved. Risk is minimized. Every movement is deliberate. Their habitats range widely, from shallow coastal waters to deep continental shelves. Some species prefer sandy bottoms near shorelines, others dwell hundreds of meters below the surface. Wherever they live, flatfish become part of the landscape itself. Their presence reshapes the micro-ecosystems of the seabed, influencing the distribution of invertebrates and sediment-dwelling organisms. Flatfish behavior reflects their environment. They are solitary for most of their lives, interacting with others mainly during spawning seasons. Reproduction often involves synchronized movements, with males and females rising briefly from the bottom to release eggs and sperm into the water column. The eggs drift freely, developing far above the seabed, where the next generation begins its life upright and symmetrical, unaware of the transformation ahead. Predators remain a constant threat. Sharks, rays, seals, and larger fish patrol the ocean floor, searching for movement or scent. Camouflage is the flatfish's primary defense, but it is not foolproof. When detected, some species can burst from the sand and swim short distances, their bodies undulating awkwardly through open water before settling again. It is a reminder that flatfish have not lost the ability to swim, only deprioritized it. The evolutionary journey of flatfish has fascinated scientists for decades. Fossil evidence reveals transitional species, fish caught halfway between symmetry and asymmetry, proving that this transformation occurred gradually rather than suddenly. These fossils stand as rare snapshots of evolution in motion, documenting one of the clearest examples of radical anatomical change driven by environmental pressure. The flatfish's role in marine ecosystems extends far beyond its quiet existence. As both predator and prey, it helps regulate populations on the ocean floor, maintaining balance in benthic environments. By feeding on burrowing organisms, flatfish influence sediment composition and nutrient cycling, subtly shaping the seafloor itself. Humans, too, have long been connected to flatfish. Species like halibut, sole, and flounder are among the most economically important fish in global fisheries. Their mild flavor and firm flesh have made them staples in coastal cuisines for centuries. Yet this relationship carries consequences. Overfishing, habitat destruction, and bottom trawling have placed immense pressure on flatfish populations, damaging not only the fish but the fragile seafloor ecosystems they inhabit. Climate change adds another layer of uncertainty. Rising ocean temperatures and shifting currents affect spawning cycles and larval survival. Because flatfish depend on specific seabed conditions, changes in sediment composition and oxygen levels can render entire habitats uninhabitable. For creatures so specialized, adaptation may not come easily. Despite these challenges, flatfish persist, continuing a lineage defined by compromise and specialization. Their existence challenges our assumptions about what is normal or efficient in nature. They remind us that evolution does not seek perfection, only survival. In abandoning symmetry, flatfish gained invisibility. In sacrificing speed, they gained patience. In choosing the bottom, they found safety. When viewed closely, a flatfish is not strange at all. It is precise. Every aspect of its body reflects millions of years of refinement, shaped by the quiet demands of the seafloor. It does not need to dominate its environment. It only needs to understand it. As the ocean continues to change, the future of flatfish remains uncertain. But for now, they lie hidden beneath the sand, eyes watching upward, bodies pressed against the earth itself. Silent, waiting, perfectly adapted to a world that rewards those who can disappear. In the end, the flatfish is not a creature of imbalance, but of resolution. A living reminder that survival sometimes means turning sideways, embracing the unconventional, and trusting evolution's most unlikely solutions.